Hi students, welcome to Chemistry online classes. In the previous class I discussed about the hybridization and bond length. In the one of the question is not completed, that is benzene. This is double bond, double bond, double bond. What is the bond length in this? Which bond length that is? Carbon-carbon bond length. Carbon-carbon bond length in the benzene is options what are given. One is 154 picometer and B 134 picometer. C A and B. D actually I wrote 129. That is not 129. That is 139. So 139 because this is the average of this 154 and 134. Then this 139 picometer. Then what is the answer? Last class little bit I explained. That is the D answer is the correct. Okay. Why it is 139 meaning? Already I explained maybe. Once again explaining this is undergo resonance. This is resonance symbol. Now pi bond at this position, it may be at this one. This pi bond may be at this position. This pi bond may be at this position. So it can be represented as a like this also. It means pi bonds are always delocalized. So single bond double bond single bond. It is changing its character. That's why the average bond length is 139 picometer. Already in many competitive exams this question is asked. So which is exception part is there that you have to concentrate more. Whatever the normally is there, everyone can read, they can write in examination. But organic chemistry, you observe in the Neet also, JEE Main also, especially in the JEE Main, they will concentrate on which is not appear in the textbook line maximum. Few questions are directly they may pick up from the textbook only. Then don't ask some questions are direct. This is common every year. Nearly 1 to 3 questions are directly they will ask from the NCERT textbook directly. We just go through the questions, then you will know that. So now from this question only one more, they will again change here. How many? What do you call? sp2 S hybrid. sp2s hybrid bonds are present from this one only. From this benzene. Options are given A 4, B 6, C 3, D 8. Now you know that how to find out the hybridization. What is the shortcut? 2 shortcuts I given. Around the carbon, at least one double bond is there, that is sp2. Then all are which one is a sp2 carbon. But here asked question is what is that? How many sp2s hybrid bonds are present? Then anywhere S is appearing here. S means yes orbital here. This is sp2. This is S. S orbital having which one generally? Benzene molecular formula what is that? C6 H6. Even at every corner one hydrogens are present. If they are write like this, then you will understand. Over here hydrogen present, then we can write the 6 hydrogen sp3s bonds are present. If like this given, then you are confused. Actually, these are very low level questions, but immediately in our mind not strike that I am stressing here. Okay, so this is which bond? This is sp2 carbon. This is which one? Si. Overlapping of sp2s that form sigma bond. Otherwise, they may write how many sp2s sigma bonds are present. This sigma bond, sigma sp2s bond. What the point? Like this question they may ask. Then what is the answer here? 6. Clear this? Again bond length respect to again it will come in the resonance or in the resonance once again. That time again clearly we will discuss. So what I want to indicate here, I am giving the one questions only. but you have to think based on the remaining other part also. Now I am giving this one question to consider. Like this. If I give like this clear structure, then you will answer. If it is given like this, C2H4, structure is not appear. When structure is not appear, that also you have to picturize in your memory and you have to answer in examination. No need to draw sometime. If time is there, you can draw. But time not in fast, you have to calculate and immediately think in your mind this picture how it is and answer. Now the question is, how many? What types of question possible from this? This is called which carbon? sp2 or sp or sp3? sp2. This is which one? S. Then which bond this is? Sigma bond. Then what? sp2 s bond. How many sp2 s bonds are present? Sigma sp2 s bonds are 4. Next, second one. How many sigma sp2 bonds are present? See, options I will give here. 1, 0, 2 and D, none. If like these options are here, then what you will answer? Somebody is 0, somebody? You first what I given here, this is which bonds? Sigma. But both should be what is there here? sp2, sp2. This carbon is which one? This carbon is which one? Is there sp2, sp2? First bond which one? Second bond? Then is there or not? How many are there? 1. And which answer is? That's why I wrote first one only. Here in explanation what also you can understand common sense, but in examination common sense sometimes not applicable here. Because what is answer that I wrote here, remaining I wrote the different options. So your answer is this one. Then we can't tell this is like pi bond is it? Pi sp2 bond, you can't tell this is. Somebody what they think here, this sp2 is pi bond. But this is not pi sp2 bond, because pi bond formed by which one? Unhybridized orbitals. These are which one? Hybridized orbital. Pi bond formed by unhybridized orbital. That also you have to think. Keep in mind, otherwise not done. Sigma bond formed always by hybrid orbitals. Hybrid orbital and another is any other overlapping. So hybrid orbital form sigma bond. Hybrid orbital form sigma bond. Pi bond formed by which one? Unhybridized orbitals. Anyone, that may be p orbital or d orbital. S orbital do not form any pi bond. Keep in mind. S orbital do not form pi bond. Which one form pi bond? P orbital, d orbital are any further. So unhybridized p or d orbital form pi bond. Clear is this? So again let me ask the question. How many pi bonds are there here? One pi bond are there. Then one pi bond. This pi bond formed by which overlap? Pi bond formed by. See, I am just a detailed discussion of one molecule. You have to apply to all other molecules. I will not discuss many examples, not presently. So this pi bond formed by 1 px and 2 and overlapping. Then second option pz sidewise overlapping. Then third py sidewise overlapping. Then fourth one pz and on, or this head on also we call it. Head on overlap, which is correct. See? Simplest question only I give now. There is no any difficulty. When you have to answer, you should know what is the hybridization. Hybridization means what is that? Nearly equal is atomic orbital mix, then it gives the same equivalent of hybrid orbitals. Here 4 you are mixing 4 hybrid orbitals will get. Now sp2 means 1 s orbital and how many p orbital mix? 2 p orbital. Generally 2 p orbital. Otherwise you can write like this 2 p orbital. Then we will get which one? 3 sp2 hybrid orbital. Because 1 plus 2 3. Generally p orbitals what are there? px, py, pz. Clear this is? Then which one we have to consider? Then somebody what we will consider? This is yes px, py. Then which is left? pz. pz sidewise overlap. This is sigma 1. This is called which one? Sidewise overlap. This is called which one? End on or end to end overlapping or head to head overlapping. Clear? Then what you will answer now? Answer is PZ. But sometimes they will not consider the PZ answer, they may consider PY. Why? Like this confusion question that will not come, but if come then you have to answer. If it is not answered, then this is the answer. Why? Because this end on, this head on, mean these are not compulsory. 5 point form by sidewise overlapping. Then we have to how to check. 4 options are given. Immediately we have to eliminate the 2 options. By looking only, we have to eliminate the 2 options. Remaining 2 options, we have to try. If you are not getting, leave it, because Neet and JEE means are negative marking questions. So if you know, then only answer. Otherwise, leave it. Okay? Then don't go for just what you call like toss, head or tail head. Don't do that. If you go for this in CET level, it is okay because there is no negative. But come to this Neet and JEE means negative marking is there. No, then answer. Otherwise, leave it. Okay? But in JEE means also some integer type questions are there. There is no negative mark. In such cases, you can go that 1, 2, 3 number is there. Anyone you can go. It's right. Okay. Not okay. Negative marks not there. So based on that negative marking, you have to follow. Now, if I want to tell you this is third is the correct answer, based on which concept I am telling this is third is correct answer. Internuclear axis, which is considered Z. You may be considering the which one? Valency bond theory, otherwise molecular orbital theory. Internuclear axis which is considered Z axis. Okay? When this Z axis is sigma 1 forming, remaining which one? Sidewise overlap. So based on that which one form? Pi bond. Already it may be also px, but px what is given here? End on over. Then which one now answer? Py. See how many concepts are utilized? Valence bond theory, molecular orbital theory, hybridization. Edit. That is known and in that also one box may be given. You just read out the molecular orbital theory in valence bond theory in the chemical bonding chapter. They given the diagram also which form the sidewise overlapping, which form the end to end overlap. Then only will answer. This type of question we ask. Now one question I will from this one only. From this one only. This smaller molecules we can easily answer. Now option is how many sigma bonds are present. Here sigma bond which one they asked? sp2 here sigma bond asked. Okay. Now total sigma bond. Here what type of sigma bonds are there? Sigma sp2 sigma sp2s. Total 4 plus 1 how much? 5 bonds are there. Now the question is how many sigma bonds? Say this is only as a question I asked. How many sigma bonds are present? How many sigma bonds? Option A, that is from 4B, 5C, 6 and D 3. Then how to answer this is? We know structure. This smaller, that's why we can draw structure. We will count 1, 2, 3, 4, 5. If very bigger is there, Then how to calculate? I will write now. CH3, CH double bond, CH, CH3 like this may be given. Option same here. 3, 6, 7, 8. Then here 8, B, 7, C, 9, D, 6. Like this may be given. Then what you will do? You have to draw the structure. Then only we clearly know that how many sigma, how many pi. Is that right? So first I am explaining according to this. Later I will give one shortcut. So it can be represented like this: CH3, CH3, then 1. Then this is 1. Then this is double bond. Then here you can write it down or up. That is your choice. Now count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Any options are there here? No. It will just unfortunately whatever without calculation I given. But in exam like this they will not give. I will write this is now 11 guys. We will leave it. Right? So now we calculate total how many sigma bonds are there? 11 are there. But now I give 1, 2, 3, 4 carbons are given. If 6, 7 given or any other complex double bond 2, 3 times given or X triple bond may be given, always you have to draw the structure. Then it is difficult because in 1 minute only you have to answer that, because 1 minute one question type will be there in the competition. Then here one shortcut for sigma bond only. For sigma bond, how many atoms are there here? 3 plus 1? 4. 4 plus 2? 6 plus 2? 8 plus 3? 11 are there?
8 plus 4
Where somewhere this thing? 3 plus 4. Okay? 3 plus 1, 4, 4 plus 2. 6, 6 plus 2. 8 plus 4. 12 are there. So, how many atoms are there here? 12. Just decrease 1. That is the answer. Anyone? Here also how many are there? 1, 2, 3, 4, 5, 6. Decrease 1. Got the point? This is a very simplest shortcut. How many atoms are there in that one decrease? But not applicable for pi 1. Only for sigma 1. For example, we will take the one inorganic molecule H2SO4. How many sigma bonds are present? 4 plus 1. 5. 5 plus 2. 7. 1 less 6 1. If you want, then try it. This is H2SO4. 1 bond, 2 bond, 3, 4, 5, 6. How many pi bonds are there? 2 pi bonds. Got the point? It applicable maximum. I tried this. If any case is not applicable, I don't know, but I tried the maximum number of molecules is applicable. You just try the whatever molecule you can pick up from the textbook and try. If not applicable, we will discuss later, but maximum it is applicable. So this is one shortcut to count the number of sigma. There is no any shortcut. Count the number of atoms in a molecule, one less. That is to identify the sigma one. Pi bond compulsory we have to calculate by structure only. Otherwise, one more shortcut form later. Next we will come back to calculate the double bond equivalent. Okay, it is based on which one? Hybridization in the bond length also they may ask, which type of bond they may ask, and how many sigma bond, how many pi bond. From what? Our heading carbon tetravalent and shape is there in our chapter heading. Then how many questions are created here? So many. So what are the, I know that possibility given. If any other also given, we can answer easily. But these are the possibilities. Next, after this, structure of the or representation of the molecule. That is called Lewis structure, compressed or condensed structure. Another is bond line structure. So rules, you should know that how to draw the Lewis structure. Lewis structure is important because it is present in the chemical bonding chapter also and in this chapter also. So what are the rules? I will give. I am not following according to exact textbook. So what I know that in the pattern I am representing here, you follow that. Central atom will be there and surrounding atom will be there. because now consider this. This is central atom, these are surrounding atoms. Okay? Ca means central atom, Ac means surrounding atom. Central atom should be less electronegative, but not hydrogen and fluorine. These are not central atom. If they are having less electronegative sometime also, but not less, central atom. Compare the carbon and hydrogen. Carbon electronegative 2.5, hydrogen electronegative 2.1, which is a less electronegative hydrogen, but also not central atom, because it forms how many bonds? Always one bond. Generally, central atom should be formed more number of bonds. Then it can be represented as a central atom. So it also forms the one bond, it also forms the one bond. Therefore, they cannot be as a central atom. Simple. Surrounding atom, there is no rules here. Other than this remaining are surrounding atom. But when oxygen as a surrounding atom, if oxygen as a surrounding atom, generally it forms like this double bond. Okay? Otherwise like this. It is also surrounding atom, but it like this can form. But if oxygen as a central atom, that it forms like this. Take one example as a hydrogen peroxide. Okay? The remaining there is no much to this. This is a very important. Central atom should be which type? Less electronegative. Other than if these two are maybe there cannot be. Remaining whatever the rules we can follow according to chemical bond, but this rule is very important. But in the Lewis structure, the second one, this first one, second one should be each atom of second period. Each atom of second period should get the octet. When you represent, that should be get the octet. But some exceptions are there. You may be studying the which one octet group, BeCl2, BF3. They are the exceptions for that. Other than exception, the remaining part should be, they should get each atom should be octet. That is compulsory condition here. Second one. So I am not drawing any new structures here. Just these are the rules you keep in mind, because based on the structure respective, there is no question they will ask. They may ask in the chemical bond, but here there is such type of example will not ask. So next one, bond line notation. Bond line notation, what is it? Zigzag manner. Longest carbon chain should be represented in the zigzag. Longest carbon chain should be represented in the zigzag. But here, if double bond is present, then that should be represented from the maximum distance. For example, I will write that this is a acetone, but don't write this acetone like this, because now angle is very less. Then it is unstable. Angle strain we call that. So angle strain is present, it is unstable. Don't draw like that. This is acceptable. This is not acceptable. Another one is, if triple bond is there, that should be linear, because why it is called linear? Here this carbon is which type of hybridization? sp hybrid. Sp hybridization means what is the shape of the molecule? Linear. Now one more example I will write here. 2 but, otherwise but 2 ion, right? But 2 ion. This is one compound. Then how many carbons are there here? How many carbons are there? How to identify based on the root word? 4. Then if name is given, how to write the structure also you can know from this only. But is given 4 carbon you have to write. So now this is called one triple bond is based on this suffix triple bond. This is the correct structure. Because how many carbons are there? 1, 2, 3, 4. This is the correct structure. But if you write like this is wrong representation. Why? It is linear, no? It is linear? No. It is somewhat angle you are maintaining it. This is called linear. From this to this. From this to this, what is the angle different? That's why always triple bond is there, it should be represented as linear. That is correct. This is sometimes you are writing, but this is not correct representation. Clear this? This is the bond line notation. And if it is represented like this, also, lone pair may be represented or not represented, that is your choice. In Lewis structure also, lone pairs are represented or may not be represented. Now based on this, they will convert one question also. Which of the following is correct out of the Lewis structure? Whatever the points are there, they will convert into the question. How? See, you also can teach this completed part. If you know the whatever the textbook line, you have to convert it into the question. How to convert now? Which of the following is correct out of the Lewis structure? Hydrogen can be central atom. B. Fluorine can be central atom. Next C. Oxygen is central atom having a double bond. And carbon can be represented as a central atom. Then carbon can be represented as a central atom. This is okay, but remaining first 3 points are wrong. Okay, like this, we have to take. It means what they will ask. You have to imagine in the our given text. Lewis structure is given. What are the questions are possible from this? How they will ask question. At least 10 possible. At least in the 5 you are imagining and answering them. That is enough for the C level. Remaining part, somewhat is there that we will teach in the class. Okay, that you have to imagine from the textbook what type of questions are possible from a given concept. That is very important. So next, these based on this are very less questions are asked from the competitive exam. So the next one part A. The next one is types of carbon. What are the types of carbons? Are the primary, secondary, tertiary, quaternary. So you know that carbon bonded with the one carbon, this is called primary carbon. Carbon bonded with the two carbon, this is secondary. Carbon bonded with the three carbons, that is tertiary. Carbon bonded with the four carbon, that is quaternary. This we know. Now I will give the molecules. Then you have to find the number of primary carbon and primary hydrogen, like this all you have to find. Now this is maybe given. In that, find out the number of primary carbon, secondary carbon, tertiary carbon, quaternary carbon. Also find out the primary hydrogen, secondary hydrogen, tertiary hydrogen and quaternary hydrogen. Generally quaternary hydrogen not possible. Because if carbon is, you know what is the primary hydrogen? At the primary carbon, how many hydrogens are there? That is primary hydrogen. Quaternary carbon already denoted, this is already bonded, and how many hydrogens are there? 0. So quaternary hydrogen not present. Now find out how many primary carbons are present? 1. Because this carbon bonded to how many carbons? 1. 1, 2, 3, 4, 5, 6, 7, 8 are there. So answer is how much here? 8. How many secondary carbons are there? This is 1. Because this carbon bonded to 1. 1. So 1, 2. That was it. So 2. How many tertiary? This is 1. This is 1. 2. Then this is 2. Then how many quaternary? This is 1. This is 1. This is also 2. Got the point here? Now calculate the primary hydrogens. 3 or 8 is 8 into 3. How much? 24 are there? So 24 hydrogens are there. How many secondary hydrogen? 2 into 2. 4. Because here 2 hydrogen, here 2 hydrogen. 2 plus 2, 4. Then here 2. Because here 1 hydrogen, here 1 hydrogen. Total 2. Quaternary hydrogen not possible. Like this, any molecule is given. Now I give open chain. They may give the cyclic also. If cyclic is given like this. Now find out the primary, secondary, tertiary, quaternary also if possible. Primary carbons, how many are there? Primary, this is not 2. That's why practice is important. We know the concept, but immediately